So I decided to make a tutorial on how to establish camera trap locations using R and going through the process of different methods to establish the waypoints and then export them into GPX format. So this is something that conservation practitioners and wildlife monitoring researchers will definitely need to do at some point in time. So I tried to put all of the resources together in this one code, which I'll put on my GitHub later. So one helpful tip, you can get most of the protected area shapefiles from Protected Planet. So I'll just bring this up here. I downloaded all of the Vietnam shapefiles of protected areas from this. So basically you'll just go to search, you'll say Vietnam, typing Vietnam, oops. And then in areas it should show up. So you can go to that and you can just download a CSV shapefile, geodatabase, whatever you want. So um, another thing is that I wanted to put here for people who aren't really that savvy with GIS, just a general explanation of why we use different projections most of the time. So latitude and longitude projections are generally for mapping because they put everything on a flat surface, so it's easy to visualize things. But the world, as you know, is a globe, so UTM projections are used for metric measurements and geospatial analyses. So latitude, longitude for mapping, UTM for measurement. Okay, so the first thing I'm going to do is open my working directory and read in the shapefile. So this is the shapefile that I downloaded from Protected Planet of each protected area in Vietnam. So once that opens, I can use map view to interactively explore all of the protected areas. I can see all of these information and things about it. Move this now so it doesn't pollute the screen. And then I want to check the projection that it's in. So I can see that it is in EPSG 4326. That's the standard WGS 84 latitude longitude projection. And I want to transform this, of course, now to UTM. So you can find the UTM projection, the EPSG number for your area based on just a simple Google search. Just write EPSG UTM, insert your study area, and then the first thing that comes up will usually show the number. For UTM, it's usually 5 digits, but Vietnam uses a projection called VN 2000, and that is 3405. So I change the projection and then I check again to make sure that nothing has shifted, nothing's out of place, and yeah, it's all good. So now I'm going to subset a protected area called Pumat. So this is just for this example right now, I'm just going to use this as the study site. So let's pretend this is my study site. We can look at it in OpenStreetMap or ESRI, World Imagery, whatever you want. The second step is to generate the locations. So we're going to use the SF um, library for this because the SP and RGDAL libraries are going to be deprecated shortly. So I'm trying to make this transition now so everybody watching these videos can kind of stick with it. So what I usually do, always check the documentation. For this, I wanted to just check what the different types are. So they have random, hexagonal, regular sampling, Fibonacci sampling. So let's just go over a few of those. The first thing we're going to do is set the seed. So when you set the seed, this just makes the random number generator in the background of R generate the same random numbers each time. So I'll give you a quick example of what that means. So I'm using stsample. I want to sample points within the Pumat shapefile that I just subsetted. I want to sample 100 random points, right? So then I'll map view that and see what it looks like. So now you see these random points. So kind of pay attention to the pattern of it. If I were to run that function again without setting the seed, and all of these random points are completely randomized again. So there's no way to reproduce that. And the reason why you would want to reproduce that is that, okay, you say, I have a study area, these are my random points, and maybe R crashes for whatever reason, and you want to take the random points that you already had. So this is just a way to do that. So again, I'll run this set seed, and we have the same random points that we had. See this one at the top. If I run this again, right, that one's gone. If I run the set seed again, then it's back. Okay, so that's what set seed does. So then you can also do a systematic sample. So this is just the same thing, but with type set to regular. And if we look at that, this is what we would call like a coarse grid. So usually when you're doing biodiversity assessments or species inventory across large spatial areas, this is what you would do just as kind of a systematic way to do it. But also we have to think about, especially if we're using occupancy frameworks, the distance between the sites. So as a general rule of thumb by the IZW handbook, I think it is 2.5 kilometers. This works for most small and medium-sized mammals. So if that's your targets, this is usually enough to exceed their home ranges, which is pretty much what you want to do for a spatial closure assumption. So we're setting this as the points distance, and then we're going to set these points, the systematic points, to 2.5 kilometers away from each other. We'll see what that looks like now, right? So if I zoom in and you pay attention to this this kind of bar over here, you can see, yeah, it's about 2.5 kilometers, right? So that's 1 kilometer there, that's 1 kilometer there, that's zero point 0.5. So then sometimes you want to offset the points, for example, of this systematic camera grid, and you want the station to have like 2 camera locations or 4 camera locations, for example, and you want them a certain distance away from each other. So then the way we're going to do that here is we're just going to take the set of coordinates, so these are the longitude or easting coordinates from our systematic points that we just generated here, 2.5 kilometers away from each other. And we're just going to add 100 to that, right? Because it's already in UTM projection, so you're just adding 100, and that means you're adding 100 meters. So if you want to do it to the south, then you would put 2 here, right? Because you would be using your latitude coordinate. But we're going to use our longitude coordinate, so this should produce a offset point to the east, right? And then if you wanted to do, what is it, southeast, then you would just do both coordinates like this. Hope that makes sense. Okay, so we're going to do this, and we're going to just run this. I put off distant v2 here because that's just what the resulting thing here is. If I run this, oops. We go and look at the column names, that's just what happens when you turn this into a data frame, right? So everything makes sense. Right, so we run this and then we check it to make sure we've done what we intended to, right? And this is 100 meters apart, right? If I look over here, 50 meters, 100 meters. Cool. So now we know how to make our systematic points. We know how to crop and mask them to our protected area or study site shapefile. So the next thing is going to be generating focused site locations. And usually people do this in GIS softwares like ArcGIS and QGIS, but you can do it really, really easily and interactively in R2. And I'll show you how to do that now. So we're just going to go like this and run this code right here. And we have all of our polygon and bounding box and marker functions right here. Right, so let's say I want to make a square in a smaller grid over here. So I'm just going to use this bounding box function, draw my box, and then just press done. right? And voila, the next point, I just extract the finished file out of that new SHP file we just made. And then I'm gonna change it to UTM and check it in map view. See, so there's the spatial file that we just made. It's already stored in R, so you don't have to go outside to any different softwares or anything. Very quick. So then we're gonna make some new points, new systematic points, right? Type equals regular. We're gonna cut this down to 50 points that we want to generate, and we're gonna put it just inside this bounding box. And we'll look what that looks like. Right? So this would be called a fine grid, right? The bigger one would be a coarse grid. The smaller one would be a fine grid. Usually this is, if you do the coarse grid and you find some really biodiverse areas like a high Shannon index, for example, and you want to do a follow-up there, or you have some rare species that you want to really focus in on, this is what you do then. And then the final step is to write it to a GPS unit for your team. So this is just transforming the points back to 4326. That's the EPSG code for WGS 84 latitude longitude. Then we're just going to repeat station and the numbers so that we can give it names. We're going to do that both to the latitude, longitude, and the UTM. And then we're going to write it as a CSV first because they might want that in the field, right? So if I go back to this shapefile, now I can see we have these two coordinate tables. So you have your geometry, which is your coordinates. If they need to put that into their GPS manually for whatever reason. And then we can also use SF and the SP argdal to write these. So I'm going to show you why I put two different methods here. The first one I'm going to use SF, and the layer name is going to be cam locations, right? So this is a GPX file called cam locations. And so I'm going to check that now on Basecamp. So this is what would pop up on your GPS. And see, it doesn't have any of the actual station names. And the reason for this is that the SF package really isn't as developed, in my opinion, as the SP package was. So we'll do that with argdal in the SP package. So we'll just say as spatial, and this will turn our points into an SF or SP, sorry, object. And we'll do the same thing with right OGR, right? And then we look, and our new thing is station locations.gpx. So this goes right onto your GPS unit in the field. And then we'll delete this and plot the other one right over top of it. So let's go here, stations, and it has all the names. So this is really good for your data sheets while you're in the field, so you can make sure that the data sheets and the cameras that are being set correspond with the data that you're collecting. Okay, so that's it. I hope it helps.